Hello. So this time we are going to try to complete this room by today, if possible. But I hope that this should not take much time. I hope. So let us see. So we have deployed our VMs already. Let's just wait for them to spin up. Okay. What is up? This. Haha. Let us just start by trying to figure out what immunity debugger is. Okay, looks like it's an official tool of some sort. Hmm? Yes, this is exactly what it is. Immunity debugger is a powerful new way to write exploits, analyze malware, and reverse engineer binary files. It builds on a solid UI with function graphing. The industry's first heap analysis tool, built specifically for heap creation and a large and well-supported Python API for easy extensibility. Okay. Cuts exploit development by 50%, simple, understandable interface. Immunity debugger interfaces include the GUI and command line. The command line is always available at the bottom of the GUI. It allows the user to type shortcuts as if they were in a typical text-based debugger. Okay. Immunity has implemented aliases to ensure that your WinDBG user does not have to be retrained and will get the full productivity boost that comes from the best debugger interface in the market. Okay, this is actually cool. Navigate to OSCP. Let's just try and open this file. Open. Come on. Okay. Let's just open OSCP. Okay, fine. So now, what is it about? So we tried to load a file called oscp.exe. What is that file actually? What is that file? Okay, the binary will be open in a paused state. So click the red play icon or choose debug run. In a terminal window, the oscp.exe binary should be running and tells us that it is listening on port 1337. Okay, let's just try to run this. Okay, debug run. And tells us that it is listening on port 1337. Where is that? Where is it telling us that? Let's try net getting. Okay. Okay, so it's running and we are in. Type help. Okay. Overflow test. Overflow one dot test. So something did change. Okay. Should we terminate the connection? Alright, sir. Mona configuration. The Mona script has been pre-installed. However, to make it easier to work, you should configure a working folder using the following command. What is Mona script? We did check it out in the morning. Let's just go over it one more time. Mona is a Python script that can be used to automate and speed up specific searches while developing exploits. It runs on Immunity Debugger and WinDBT. Now mono.py into PyCommands folder. Okay. Used to automate and speed up specific searches while developing exploits. Interesting. Okay. Mona config dash set working folder c directory Mona /p. Okay, something did happen. Create a file on your Kali box called fuzzer.py with the following contents. We did try this in the morning, but we'll do this again because of course our VM died, and if we keep on doing this, moving at this pace, we need to get over this a million times, I think. So let's see. Okay. So what it is actually doing is that overflow 1 plus a is trying to send this value a couple of times, and each time it is adding 100 more A's, right? That's why we get to see. So this is 200 A's, 300 A's, fuzzing crashed at 2000 bytes. Okay. The fuzzer will send increasingly long strings. With one of the strings, the fuzzer should now exit with an error message. Make a note of the largest number of bytes that we were sent. Okay. Crashed replication and controlling our instruction pointer. Create another file on your curly box called exploit with the following content. So what is going to be different this time? Let's see. Exploit.py. Sending evil buffer done. Okay, well, what did it do? Imports socket. Prefix is something, offset is something, a into offset, that's 0, that's nothing. Okay, fine. Buffer is equal to prefix, that is overflow 1 plus overflow. Okay, overflow offset, so that was 2000 plus ret, and what is ret, and we don't know. Padding, payload, postfix. Run the following command to generate a cyclic pattern of length 400 bytes. It's going to take a while. So what we are doing here, okay, what we need to do, run the following command to generate a cyclic pattern of length 400 bytes longer than the string that crashed the server, of a length 400 bytes longer. Copy the output and place it in the payload variable. So it's 2400, is it? 2400 it is. Why don't we just download this time stuff on our machine as well? Okay. Let's go. Metasploit framework, exploits, external. It is going to be in it is going to be in which directory? Tools exploit pattern. Hey Ash, why don't you type in here in the chat box? That will be easy for me to actually answer. Huh? You can hear me, right? Pattern create HL2400. You did not get a. Twitch doesn't allow you to use dot in usernames. Are you there? Okay, something did happen. Sure, sure, take your time, explore. Uh, Once you're done exploring a bit, I'll tell you about what we are actually doing here, what I'm actually doing here. It is some really interesting stuff. Just take your time, explore, check everything out. It's more or less like YouTube, slightly different than YouTube, but yeah, the basic concept is the same. The same method as before and click the replay icon to get it running. What is this? Ah, fuck. Give me back. Mm, let's run OSCP again. How disconnect this? You will have to do this each time we run exploit.py. Is this it? Okay. Let's try to run a hard exploit again. What is this room anyways? Buffer overflow. Crap. Hey. Now we can try and see if our exploit really works. Huh? It is not really. I'll try to change. Okay. Aha. Done exploring. So, okay, it will take me some time to explain what I'm doing here. Okay. And before that, how much time do you have? Do you have some time? Because accordingly, I'll set. I'll speak about stuff accordingly. How much time do you have? You have 22 minutes till 9 o'clock. What then? Anyways, okay, regardless, let's begin. So there's this website called, I'll take it really slow, okay? You need to ask questions whenever you are stuck or cannot follow. whatever we are doing. So there is this website called tryhackme.com. On this website, there are multiple learning paths. Okay, by learning paths, we can consider them as subjects in a particular course. Okay, like cyber defense is a course, complete beginner is a course, offensive pen testing is a course, CompTIA pen test is course, web fundamentals is a course. So of course we pick a single course that is, for instance, a complete beginner. When we open this course, okay, there are a couple of rooms here. Okay, so rooms can be considered as chapters in your syllabus for a particular subject. All right, let's just open a particular room. Things will start to make sense. Okay, I know just trust me, they'll start to make sense. So inside each room, now you understand the breakdown, right? So there's this path which can be considered as different subjects. Then inside that there are different chapters, and inside that these are the chapters. Like, these chapters are called rooms. Okay, what are we doing here exactly? We are learning new things. So as I have told you before as well, that there are two aspects to learning anything: the theoretical aspect and the practical aspect. So here, are you still with me, Ash? So I'll just give you a very brief walkthrough of a very superficial walkthrough of a particular room. All right. For instance, this room teaches you about web fundamentals. So the first section is introduction. Forget about it. How do we load websites? All right. So there is this theoretical stuff involved. For instance, finding the server, how does that content get loaded, how HTTP requests are handled and all. And according to this, there are corresponding to this, there are a couple of questions below every subsection of this chapter. For instance, what request verb is used to retrieve page content? So you already know that get is the right answer. What port do web servers normally listen on? 80. What's responsible for making websites look fancy? It's CSS. So the gist is that it provides you with a basic idea about a particular domain. Okay, how things work, and at the same time it provides you with a hands-on information about whatever you're learning. Okay, a very hands-on information. So this entire website is based around information security. Tryhackme.com. So all these parts, all these subjects, they are based around information security. People come here, people learn, people compete here. Okay, they try to solve rooms, what of this chapter sort of try to solve it. So that is what people do there. Now we can talk about, say, one room in particular which I just solved yesterday. Okay, did you understand everything till now, whatever I told you? So this is a brief overview about what this website is and how things happen here. Okay, now let's think. I'll drop a link in the chat section. Okay, this is the website. So anyways, I'll give you a very brief walkthrough about. So now I have superficially touched what this website is. Now I want to give you a feel of how things are here and how interesting things are. Okay, how I mean, they are very amazing. I mean, a couple of things here are like really amazing. So for instance, I'll tell you. Now I want you to focus here. Just can you read this code in your head and can you try to understand it? and let me know if you just follow this code. That's all. It's a very simple code, nothing fancy about it, nothing at all. You understand it, right? Okay, so now can you think of a scenario where this situation will hit? Can you think of a scenario in which this situation will, this if part, if statement will actually execute? What scenario is that? I mean, take your time, it's okay. It is a trick question anyways. So no, yeah, forget about volatile. So volatile has nothing to do with this. It's all right. Forget about volatile. Think as if there's no volatile keyword used here at all. It doesn't matter. I mean, you can say that I cannot think of a scenario in which this particular if statement will hit. I mean, it's perfectly fine because that is what I want you to say to complete. Yeah, it's cool. So actually, whatever we have learned till date suggests that, of course, if we have initialized a variable with a particular value, there's no way that we can change that value. And if we are inside, if the code is fixed, just by executing this code, we cannot change the value of variable. All right, we simply cannot. Now let's change that perception. All right, I'll show you that magic trick. Give me a moment. Let's just quickly write this code down. Okay, actually I gave sort of, this is what it is, right? Yes, buffer. All right. Then if variable is not equal to 0, printf not okay, else printf yeah, we cool. Let's go. Let's just take a quick look if we haven't missed anything. What are these dollars? Remind me. So it's just in Vim, these dollars are just end of statement. Okay, so sorry. Wait a minute. It means that there's no, you see, that there's no character after this dollar. Okay, you see, here, I'll have spaces, these dollars will keep pushing on the right. This, it means that it is just the end of this line. Good catch though. Okay, so we have our word, we have our whatever it is. Sorry, I need to check one more thing. I'll actually never get hang of my mechanical keyboard. I do commit a lot of typing mistakes. So 1, 2, 3, yeah, we cool, right? This is what we expected. So it will print yeah, we cool only when the value of that variable is 0. All right, now let's try to push more values than there, then this buffer function can actually, buffer variable can actually hold. Okay, What I mean to say is that what we have allocated is we have allocated only 14 bytes of space to this variable. Okay, so what is going to happen if we allocate more space into this variable? Any idea? Because get as buffer will try to allocate whatever you are going to input into this program. It's going to allocate whatever you're going to input into this buffer variable. Okay, so what is exactly going to happen if you are going to store more values than the allocated space? What's going to happen? Because if you remember how memory works in C is that buffer is actually the address of the initial uh, place where the first byte of the input will be stored. Do you understand? Are these two variables at contiguous location? That is true. Buffer and variable are in contiguous locations. That is true. So right after buffer there is a space, there is some space for variable. Okay, I think you're almost there. You are almost there. You understand where I'm about to go. So 15 character, that is true. So yes, that is true. So if you have noticed, would change the value. That is true. That is true. So you see, it's not memory safe. So what I did here, let's see. So I tried to input this string. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If I would input like 14 bytes of data into this, we are cool. And the value of variable is like 0. How do we know that they are at contiguous location? We have the source code, right? We can only tell that whenever it is at whenever we have a source code, we can like read the source code and tell that whether they are at contiguous location or not. Because if they are declared as adjacently, they are going to be in contiguous location for sure. But we need to know the source code to actually exploit this. Do you follow? Wait, I'm looking for a flag. I forgot the value of that flag. WL something. What was it? Hold on. Hold up. WALLFNO stack protector. Whatever the hell this is. Okay, let's go back. Bear with me. I'll answer whatever you're asking. Say, and then what's this music? It's nice, right? Isn't it? Feels like I'm in a restaurant. Maybe, but still, it's nice. It's a very expensive restaurant, if you may. So it's some background music just to to focus. Sono cocoon maybe. Anyways, okay, let's get back to our problem statement. So anyways, your question was that how do we know that they are at continuous location, right? So I mean, just by looking at the source code, you can tell that they are at contiguous location. I mean, do you understand? You do understand that we know the source code beforehand already. In prior, we know about the source code. If that is given, then adjacently declared variables will be stored adjacently in the memory. Because why why would that not be the case? Why? What's your question? Do you understand? Do you follow me? If you do not, what's your question again? We are assuming that they are at this location. We are not assuming. That is the case. That is how it works. That is not. That is. I'll show you that. Let me see. How can prove that? How can I prove that to you? What if there's no space left? That's not going to happen. How can that happen? If there's no space left, first of all, we are talking about RAM. Okay, so it's not disk space. And if there's no space available in the RAM, then what are we even doing? I mean, our program will not run at all. That is valid, right? If you have a 4 GB RAM stick installed and your program needs like 5 GBs or something, it's not going to work at all. If a code and it cannot, so okay, let's talk about different possibilities. What other possibility can there be? So you are saying that if they can be randomly stored in different scattered location, but why? In that case, like there will be a lot of empty space between two variables, right? Yeah, I understand your point. So in that case, there will be a lot of empty space which is used by nothing between the two variables, right? Think about an array. It's a continuous block of memory, right? It can also be scattered into different memory locations. Each byte can be scattered across the entire RAM, but we do have a contiguous block of that array, right? Just to keep things in order so that we can, that memory access is easy. Doing accessing that memory is easy for us. Do you understand? That is how it works actually. Imagine there are only two type of blocks of memory available. That won't be. I understand what you're trying to say. How can that be? It is, memory is always filled in a contiguous manner. It cannot be that a different chunk of memory is being used. It cannot be. There's no reason to do that, right? Read the note. What do you mean? Read the note on the screen. Note. No, 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 no. So what this is saying, I know what he's talking about. So what he's saying is that a continuous chunk of memory can be that we are trying to allocate 14 bytes of memory, but again it is saying that it can be that depending on what bit system it is, that it can store memory in, say, a fixed chunk of say 8 bytes or 16 bytes instead of like 14 bytes or some random chunk of what the user has defined. And again, they have also said that in that case we are going to waste that memory due to padding somewhere. You might have said something. Yeah, padding here. So even if we are using just 12 bytes, we are going to pad it. So that's a waste of memory. And that we only that we do that only in the case when it is not it doesn't align with our uh, number of bits that we have, bytes that we have. Whenever it doesn't align with that, only then we pad it. Anyways, from the C code, you can see that integer, variable, and character buffer have been allocated next to each other. You see that, right? Since memory is allocated in contiguous bytes. Ah, this is an important bit. You see? Hmm. So we are clear on that front. Now let's get back. So now what we are going to do is we are going to input again. We are going to input. So till 14 bytes, like it was all right. Uh, if we are cool, okay. If we are only inputting to like 14 bytes, we can also input like 1 byte of data. We are all right with that. But as soon as we switch to like say higher orders of bytes, say 15 bytes, as you pointed out, not okay. By not okay, we mean that the the value actually overflowed into variable. You see, so it reached into this part of our code, which is not okay, which means that our value of our variable changed. It is definitely because of gets. So again, even when you compile this program, it will say that the gets function is dangerous and should not be used, though they have not explicitly mentioned why that is the case. But you can see that in gets method, like it doesn't have any check upon that how much input, how much what will is going to be the size of the input that it is going to take. You see, yes, yes. I can input like 1,000 bytes in this. Let's just input 1,000 bytes into this program. Huh? Why not? Uh, say see, though it is showing segmentation fault, but it is still taking the data, right? Be cool. Not okay. We are able to input at least segmentation fault. So again, this segmentation fault is a reason that we are getting. Okay, can you guess? I know it's a very hard question, let me tell you. But can you guess why are we getting segmentation fault for 100, but we are not getting segmentation fault for say 15? I mean, 15 is a perfectly acceptable number. Even 20 is. Maybe 30 is. 30 is not. Do you have any clue? I mean, I totally understand if you do not have a clue. It's a very hard question, mind you. You're close. So the actual value is actually 25. So we can treat like 25 bytes of data. What is actually going on right now is, so this value is not just overflowing into the variable. Now it is overflowing. Do you want me to wait? Think about it. Any idea? Yes. So what happens is my actually I know I will narrow down to why 25, but before that, let me tell you what's going on here. So what is exactly going on here is the segmentation fault. Hey 3D Prema, long time man, long time, very long time. I don't know when did I last saw you, man. Where were you? How are you? So we were discussing about buffer overflows here. Just give me a moment. I'm in the middle of something 3D. So Ash, so what is going on is now the next thing that it can overwrite is, so we know that like 14 values, 14 values overrode buffer variable. Now a couple of values wrote overwrote variable. Now the next thing it is going to target is the return address of this function. Okay, so what happens is that even the return address is in the contiguous block of memory. So every function, yes, what man, there are two things. It's not 14. Do the math again. It's not 14. Anyways, it's not 14 still. Actually, it is 16 because we are going to anyways pad it with certain value. When variables are allocated, they would need to be aligned to a particular size. Okay, so this might be let's find out what architecture this is. It's a 64-bit architecture actually. Okay. Okay, so it will be aligned as per 16 bytes. Yes, buffer overflow 101. Yeah, man. Do you have any idea about how it works? How buffer overflow works, not this particular problem. I mean, how buffer overflow works in general. Okay, so if a 12-byte array is allocated where the stack is aligned for, actually we need to figure out how the stack is aligned. I don't, right now I do not possess the tools to do the math, to be honest. Okay, I need to find out how stack is aligned here. A 500x. Is it RSP or SP or ESP? What are the registers? I've forgotten all the commands, man. I'll answer that later, Ash. Right now, I myself have needed to do some digging to actually get to understand what's going on. Okay, but it is something along those lines. I'm sure that I need to find a perfect stack size, and then I need to add that. But anyways, so why we are getting segmentation fault is, so the next thing that is going to get overwritten is, okay, let's see here. Yeah, so the next thing that is going to get overwritten is the saved registers and then in turn the return address. Okay, so as you know, everything in C is a function, all right? Even main is a function, so it has got to return anyways from the place where it is called. It has got to return. Now if that return address is overwritten, so there's a segmentation fault because pointing it is asking the entire function to return to some place in the memory which has no meaningful program execution or something. You understand, there are no meaningful instructions there. Do you follow? So this is what is going on. This is precisely what is going on. Beautiful, isn't it? Say it. It's beautiful, right? Let's just make note of this flag, and I keep on forgetting this flag. Who would have known? I mean, even when I saw it for the first time, I was impressed that it's so easy, but yet so hard to actually catch that this particular thing can also happen. See? So this is actually Doom Emacs editor that I'm talking about. Something Because of some reason the background color is fucked up. I don't know why. I'll fix that at some point. I don't know. But anyways, this is Doom Emacs editor. It is incredible, incredible. Hands down the best editor I've used. Best terminal editor I've used. So that is what buffer overflow is as. Now, if you level that thing up, what I mean is if you look into a little more advanced portions of this concept, so there are just so many things that are lying here. If you want, like, you can follow this. Now this is a new room called buffer overflow prep. That was a different room. That was a very basic room. This is a new room. In this room now we are going to do the exact same thing, but now we have tools at our disposal. Now we can actually see where we have the address and the value that address is holding. Okay, the address in the memory and the value that address is holding using certain tools that are provided here. Sure. Bye bye. Bye. 3D Prema, I'm sorry. Are you still there? Let's see what is going on in here. Copy the output and place it into the payload. Variable of exploit.py script. A-D-A-L-E-K-E-A-L-3-K sec. Thanks for the follow back. I'm sorry, I just need to hop in for Delec sec. Delec sec, man. What's up? I just need to go for dinner, man. I'll take like 5-10 minutes, alright? What's up? Do you stream as well? I mean, I think I've seen you, man. Do you stream as well? Hold on. Aha! I do. I follow you in fact. That's why it struck me. How is it going? Yeah, actually, I'm sorry. So I was away from my mic. Uh, so I was saying, actually, I do follow you, man. I watch your stream sometime. So that's why the name struck me. Delk Sack. Delek Sack. Thanks for the follow, man. So I was just finishing. Yeah, yeah. I just put my mic aside for. Yeah. So actually, I think you solve try hack me rooms as well, right? Please correct me if I'm wrong. I have seen a couple of your streams, if I'm not mistaken. Ah, you do. Offensive track. Yes, you do. So you might know already that right now, like I'm trying to work on buffer overflow prep room. This room, buffer overflow prep. It's a nice room, man. Actually, I was always a little It's part of offensive security room, so security path, or offensive pen test path. path. Yeah. So here it is, buffer overflow exploitation. Incredibly nice concept, and like everything is amazing about buffer overflow. I love this. So, anyways, this was the task for today. We are cracking this room. I'm going to work on that probably this week. I want to finish building that box. Ben, do you have a Discord server or something? I'll probably hop in. Oh, can you drop a link here? I'll just hop in. Actually, sure, no issues, man. Even my Discord has like no, not, there's not much activities going on there. So even on my Discord, so it's all right. Can you drop in your Discord? Actually, I need to be in the loop, like what other people are doing as well. Thank you, man. Aha, InfoSec Playground. Great, man. So I actually am starving right now. The Lexec, I'm sorry. I will just quickly take a short dinner break of like 10 minutes, get back, and get going with this machine, alright? So just give me like 10 minutes. I'm really starving. Okay? Thanks, man. Hey, thanks for hosting me, man. Thank you. Oh, that's so kind of you, man. Thank you. I'm a very small streamer. I barely have any viewers, but thank you, man. Thanks a lot. Thanks for the gesture. I wish I could repay. In fact, I will, but I have like very few uh, viewers, anyways. Let's see, where was that setting? Where is it? There's a setting for hosting people. Raids, drops. There's a setting for hosting Twitch channels. To auto hosting. Where is that auto hosting? Account settings, is it? Not there. Hey, Marshall. Is it a raid? Really? Oh. Let's hide this banner. Hey, Chad. I know you did. Nobody's going for a dinner break now. It's a raid. Oh my god. You're making me anxious again, Chad. How are you? Thanks for the raid. Hey, thanks for the follow, Marshall. Much appreciated. You were streaming. I need to turn on notification. I mean, they're disabled for my entire app. I need to do that. All sure, man. Sure. Thank you so much for the raid. Thanks, man. Thank you. At school, man. Anyways, I need to. What should I say? A bit late for dinner. It's actually 9:30 here, and yes, a little bit late for dinner, but it's all right. Actually, I mean, I want to be. I want to respect Chad. He just raided me, so it's all right. I'll just hold it off for a while. So, anyways, hello everyone. So, what I am again, just like Chad, I also work on cracking tryhackme.com rooms. Okay, so the room that we were covering today was based on buffer overflow. So if you people are not familiar with the concept, I will just quickly tell you what it is. Okay, so buffer overflow is like variables are actually stored in a contiguous memory location. Okay, so if a variable is inputted a certain value which is more than its allocated uh, size, what I mean is like a particular size is allocated to that uh, variable. Okay, if you input more values in that variable, that the value will actually overflow into the next variable, if you can follow what I'm saying. So that is what is buffer overflow. So if you want to know more about it, I mean, it's like it's an easy concept, but it's a tad hard to sort of uh, debug and all using GDB. That's what I find is a little hard. So if anybody is interested, like, they can try and check out this room. It's a very easy room for to understand what buffer overflow actually is. All right, so this room that I am doing right now is sort of an advanced version of that room. Okay, called the buffer overflow prep. So in this we are provided with a Windows VM. Okay, and a tool called immunity debugger. This immunity debugger is sort of, from what I have seen till now, is sort of a substitute for GDB and a couple of more things. But yes, it can act like GDB as well. So it's a GUI based GDB sort of stuff, uh, tool sort of, you see. Here we can see that what value is stored in what address, or what address stores what value. You see, this is what it is. So as we were navigating through this, we tried to and now at this point, actually, it's sort of a custom. No, I'm not a Mumbaiker, but close enough. Not a Mumbaiker though. How did you know? My accent, maybe. So immunity debugger can actually also be used to, what should I say, unpack or Marshall von Dunes. So that's sort of a Dutch name, and I'm not a Mumbaiker, man. I'm from Gurgaon, Delhi, close to Delhi NCR. So yeah, not a Mumbai girl though. Congratulations, 100 messages today. So okay, so in this, like, we can also find, we can also, what should I say, dissect binaries as well. For instance, if here we can open different, okay, let's open this binary oscp.exe. So as we can see here, that we can see the machine code, okay, behind this binary. And yeah, yes, we can even execute this binary from this sort of control panel sort of thing. So we did okay, so now let's go back to like reading what's going on here. Okay, so forget about fuzzing, let's go back to crash replication and controlling the instruction pointer. Creating another file on your Kali box called exploit.py with the following contents. Okay, we did create our pattern here. This is our pattern. Yes. Let's run this exploit. Could not connect, of course, because it's not running. Okay, copy the output and place it in the payload variable on Windows. The open OSCP. On Kali, run the modified exploit.py. Script should crash the OSCP server again, this time in Immunity Debugger. In the command input box at the bottom of the screen, run the following Mona command, changing the distance to the same length as the pattern you created. What does this do? Mona should display. What does this do though? Sometimes these people do not tell what a particular command does, so we just need to go out in the wild and figure out what it does. So find MSP, is it find MSP? Rerun the exploit, the application should crash to find the exact offset of the crash use. No, Talexac. So actually this is a disposable VM I'm using. So I used to use Arch Linux, but right now this is a disposable VM I'm using over Windows. That is because I absolutely hate Windows. I have honestly never worked with Windows before. This is the first time I'm trying Windows out. But actually I have to run a certain program in the background which requires me to run Windows, okay, even when I'm streaming. So for that I'm actually using this VM so that I can have a host machine which uses Windows. Yeah, I don't want to, but I have to. Anyways, Let's go. So find MSP. What is going to do? The application should crash to find the exact offset of the crash. I did. Actually, yeah. VMware in Linux. You had issues running VMware in Linux. So you mean like running Windows in, I mean, Linux should be the host machine and Windows should be the guest OS? Are you asking? Are you telling that? Are you saying that? Yeah, no. So there was this issue of actually what my processes are using GPU in the background. So it was incredibly hard for me to actually set the GPU pass through from the host machine to the guest machine, you see. So this way, since Windows is my host machine, I do not need to go through that drill of like GPU pass through. Okay, because there are some issues with the BIOS or something that I just cannot make my way through it. Okay, I just simply could not. Oh yeah, no. Actually, I was using VirtualBox, and in fact, I tried VMware as well. No, no, I just tried VirtualBox. It wasn't working with me, or working for me. It wasn't. That's why. So I came across a simple solutions, or you can call it an overkill. I just installed like 32 gig, one more 16 gig RAM. So now it's a total of 32 gig RAM, and like I can easily allocate like 10 GBs of RAM to this VM and use it like as if it was my host machine. So it's very seamless. Actually, kernel virtualization module personally it seems to cause trouble, man. I couldn't make it work. I mean, there were driver issues and all, but again, it might be, and moreover, what I believe is that VirtualBox is actually a little more buggy than VMware. Like VMware is a very sorted thing, but VMware is again not free for commercial purposes, so that's why I do not prefer to use VMware. I'm bound to use VMware. I don't want to. It says non-commercial use only. I'm just bound to use this. I most likely will switch into something else later at some point. Proxmox is another one if you want to go to that route, but we can talk about that later. I'll give it a shot. I'll actually write it down, Proxmox. Again, these I hate to admit, but most of these VM open source ones are like they do not have this. They are not very reliable. I've tried multiple open source ones, but turns out only VMware was a good fit. I'll give it a shot though. Maybe this time it will work. Proxmox. I've seen a few YouTubers show how to get them working. Yeah, uh, I will definitely give it a shot. Try to understand how it works. Okay. Need to have a to-do.md. Fuck. Plus, NVIDIA has the ability to do virtual GPU, so you can do hardware pass through with one GPU on multiple VMs. I actually want to use one single VM, but GPU pass through was incredibly hard, honestly. And there were some driver issues, as I said. So I just try to keep everything simple. Um, anyways, so and also During pass through, I think I tried pass through like half a decade ago, on VirtualBox, if I'm not mistaken. I could actually notice a drop in performance. Okay, because my apps are very graphic GPU extensive, so I could actually see a drop in performance when I was using this GPU pass through. So again, doesn't give me a very assuring feeling. See. Anyways, may I interest you in one of the projects that I did like 3, 4, 5, 6 months ago? 3, 4, 5, 6 months. Yeah, good going. Because actually, I'm sort of like I love doing that. Are you still there, Delixec? Would you like mind taking a look at this? Just a sec. You did try it out. You did check it out. Nice. Yeah, it is actually nice. Mono should display a log window with the output of the command. You cannot click the window menu and then log the data to view it. In this output, you should see a line which states EIP contains normal patterns. Generate a byte array using Mona and execute the null byte by default. Make the location a pop-up window should appear labeled Mona memory comparison results. Let's see. Okay, let's try to run this. Okay, Mona should display a log window with the output of the command. If not, click the window and okay, if this output in this output you should see a line which states EIP contains normal pattern. Where is that line? EIP contains normal pattern something something something. Update your exploit PY script and set the offset variable to this value. Set the payload variable to an empty string again. Set the return variable to BB. So our offset is 1978. Then exploit. So it should be 1978. 1978. And that payload is payload equal to empty string again. Okay, we did send. Set the payload variable to empty and set the return variable. Okay, so return variable should be the return address, if as far as I can make out of. 1, 2, 3, 4. Okay. Let's see. Mona, please go away. Mona, please leave. Okay, let's just. Okay. We are running this again. We're sending our evil buffer again. Now, what do we expect? And run the modified explorer. EIP register should now be overwritten with 4 B's. Here is the EIP register. Aha! Amazing. Okay, let's see what we did. Let's go back and see what we did. We created a cyclic buffer of 2400 length. We run this command to get an offset. What's going on? Let's go back. So find MSP distance provides us with the offset value. In this output, you should see a line which states EIP contains normal pattern. Yeah, that's right. But okay. But what is going on here? Generate a byte array using Mona and exclude the null byte by default. Okay. Note that the location of the bin that is generated was set as per Mona configuration section for this guide. Now generate a string of bad gas that is identical to the byte array. Following Python scripts can be used to generate a string of bad gas from 0x, x01 to xff. Okay. Update your exploit UI and set payload to the string of bad gas. Restart oscp.exe in immunity and run the modified exploit.py again. Make a note of the address to which ESP register points and set in the following Mona command. Above the window should appear labeled Mona memory comparison results. Not fine. Not all of these might be bad gas. Sometimes bad gas cause the next byte to get corrupted as well. Or even the fact the rest of the string. The first bad gas in the list should be null bytes since we already moved it from the file. Generate a new byte array in Mona. Restart OSCV in immunity and repeat the bad car comparison until the result returns an returns unmodified. This indicates that no more bad characters exist. Oh my god, this is actually a little hard to follow because they've skipped through a lot of information. Anyways, we'll make our way through. With the OSCP to TXC either running or in crashed state, run the following Mona command. This command finds all jump RSP instructions. The results should display in the log data window. Okay, at this point I really need to sign off. I'm super starving, like since an hour, over an hour. In fact, now we'll continue tomorrow, 6 or 6:30 a.m. sometime. So it's around 8 hours from now. Okay. Yeah, man. Thanks for hanging out. I thought you left. I'm actually starving, man, and I need rest as well. So I did stream like at 6 a.m. in the morning for one and a half hour, I think, and then I had a long 8 hours of 8 hours working job, and I went to gym, and then I started streaming again. My brain is melting, meltdown imminent. We'll do this tomorrow at some point. We'll do this tomorrow. Night. Thank you for joining in. Really appreciated. If I'll find time, I'll definitely drop into your streams as well. Delexac, thanks for hanging out. It was nice talking to you, man. Thank you. Good night. Goodbye. Bye bye.